Welcome, and Mr. Francois, and today we're talking about bulb brightness. Now, bulb brightness can come from several different things. As we can see here, this setup that we have is a very interesting one. We have just a regular light bulb here, and we can see, how lit up it is. Now, if we want to compare this brightness to other brightnesses, what happens with series and parallel when we add in another light bulb or another resistor or something as such? So let's investigate that. So if I take a point here and I separate this out and I'm going to add in this other light bulb. Well, let's take a look. I mean, does this look as bright to you? No, clearly it does not. What series does is that every time you add in another bulb in series with something else, it ends up decreasing the amount of current flow. You can see all of the little electrons as they travel around this circuit here. They go up through the light bulb and going through the little filament, they give off some energy, which is in the form of light. But if we went and we take a look at this, we can see clearly it's not as bright. The brightness goes down for every bulb that we add in series to this. But what about parallel? What happens at parallel indeed? So I've set up a basic parallel here. We can see what is happening. We can see that the electrons are flowing around. Now let's compare this. I mean, does the brightness actually change? Well, let me take off this top one. No, the brightness actually just stayed the same. All it did was stay the same. I mean, if I connect this again, the lines that indicate the brightness from the first one here do not move. So adding a bulb in parallel to everything else that is on the line, okay, to everything else that is on the line does not change the brightness of the original bulb. Okay, so even if I went and disconnected this junction, and I move that over here, and I'll add in another light bulb. Okay, and we'll move that light bulb over here, and we'll add another wire, so that now there's two over here. Oh, I made a little bit of a boo-boo, because remember, our light bulbs, they don't connect both at the bottom. They connect one on the side and one at the bottom. So let me disconnect the one up here once more. Okay, so we can see, once again, it's dim because we have that series of the two bulbs being there. It's very dim. However, if we go and we connect this, again, it does not change how the brightness is of everything that was originally connected. Okay? So, if we go and we look at this and we say, well, what about if we combine things? What if we have a different setup? Well, let's take a look at that. So, here we have a 2 series one. Now, I have an extra bulb already lined up to go. So, let's take a look and examine what happens when we add another bulb in parallel to only a piece of the full circuit. So we're not going to add it in parallel to this one over here. Instead, what we're going to do is we're going to add it in parallel to the first one. So let's take this and add it on there, and we'll take this and add it on there. And now we see a drastic change, right? Clearly, this bulb here has gone down in the amount of current that it's getting. We can see the ball's moving very slowly there, and it has very little amount of brightness. We can see the lines are almost barely visible. I mean, right here and right here, but they're very much shorter, indicating a lot less brightness happening. But the one that we added in is just as bright. I mean, it's, the lines are about the same size, right? But this other one, the one that we started off with, the one that we didn't connect to, that increased. So This happens because, well, let's take a look at it. I mean, you have double the amount of spheres coming in these directions, right? It's two entrances, and both of them are going and being fed into here. And so we see this one is in fact getting twice as much. So it is in fact being, it gets a lot more. So this one, anything that's on what I call the main line, okay, increases. And anything that was part of the circuit that is now in parallel to the thing that you just added is now dimmer, okay? And that's because this one, you're not adding a completely new path like when we added it in parallel to everything. In fact, what we have is we're reusing a good portion of the same path. We are reusing this path here, and this path here, and this path here, and here. We're reusing those pieces. We're reusing them. So when we reuse them, they get loaded up, but they have their own kind of resistance. This quality that slows things down, that allows it to slow down and give off some of its energy in the form of light. They have their own resistance, which means that it won't go. It will take a little bit of getting used to. You've only made it easier for particles going through this section because now they have two paths. They can go this way or they can go this way. It doesn't just create an entirely new path. You're still using some of the old one, which means that our current and our brightness likewise suffers where there was originally. Okay? So if we look at the current that's coming out of the battery, yes, it has increased, but not doubly so because you're still using some of the same path. This light bulb is still resisting. It's kind of pulling double duty in a way that it is resisting the more current that's coming through. And over here, seeing as how it's not going to be pumping out double the amount of current out of the battery here, instead what you end up with is a lessening effect on the original, and this one seems to match it. So here's now the question: what happens when we add in something in series to something that's already part of a parallel? So let's add in another light bulb into this area right here with this light bulb. Okay, so here is something. It's very similar. So you see how I have a new light bulb right here, and I haven't really changed anything, not just yet. What's currently happening is I have a little switch right here, which I currently have set. So this is acting as a jumper around this light bulb here. And what is going to happen is that as soon as I release this switch, as soon as I undo it, as soon as I turn it off, essentially, it's going to break that line. And what's going to happen is all of the electrons are going to be forced into going into our new light bulb. So let's see and compare what happens. So if I let this up, oh, well, didn't want to work for me there. There we go. So I let this up, and we see a change. So go back and go up. Okay, so as soon as we add in another one on this line, our light bulb that we have in series with it, that we're going to be making in series with it, look at how its lines change. It goes from having some to basically having none, right? So let's see. So yeah, it goes to none, a little bit to basically none, and our new light bulb is matching it. So we go from here to here. So now let's take a look at instead this light bulb, the one that's in parallel with it. So the one that's in parallel to where we're adding in the series. So again, I'm going to release up this, and we see it goes from being kind of dim, same dimness as our other one started off as, to being a little bit brighter. And that's because now you're effectively paying two tolls along this path. You're having two things that slow it down. So Now you have to think about, well, if you're going to pay 2 tolls, there's going to be a faster movement rate around this side, and there's going to be more current going through that side. So if we add in another one up on the center parallel, then the top parallel is going to have is going to get a little bit more current. But let's take a look at our one that's off on the side, the one that's part of the main line. So not part of our parallel up here, and not part of what we're adding it to in series, but the one that's part of the main line. So let's look at how it was. Okay, we got fairly decent long lines, and then flip the switch, and now it's a little bit less. See, more, because more lines, less, more, less. Okay, so by adding in the series here, we decrease the amount of current that's coming out of the battery, still, just like our original series was. However, when we add it in on a parallel, okay, when we add more to the parallel here, that decreases it there, but it picks up a little bit on the other part of the parallel. Okay, so our rules are so very quickly, these are the rules that we noticed, that when added in series to the whole circuit suffered a decrease in brightness and current. That when we added it to part of a parallel, the main line suffered a decrease, and what it was added to suffered a decrease. The other side of the parallel, however, suffered an increase in brightness and in current. When we added it in parallel to the whole circuit, the main line suffered an increase, but the rest of it showed absolutely no change. When we add it in parallel to part of the circuits, only putting it across part of it while there are other things still on the main line increased, the battery increased, but the part that is now in parallel decreased. Okay, so this is Mr. Francois signing off. If you have any questions or comments, please leave them down below. Have a wonderful day.